Greetings and welcome, friends. Today we're talking about a concept that may scare my wife, but we'll talk about it anyways. Infinite sequences and series. That's right, my wife is an apeirophobe, as many of you might have suspected, someone who has the fear of infinity. Ever since she was a small child, her parents would find her just waking up in the middle of the night, crying out about the numbers and make them stop. And it was terrifying to her. So yes, true story. So I apologize if I'm bringing back nightmarish childhood events. So what is an infinite sequence? Well, it is a sequence with infinitely many terms. Rather redundant, not much of a definition if you're one for using definitions that don't have the word in itself. Right?
You're a master of the English language.
I'm amazing. So here's our first example. It says, find the nth term of the infinite sequence. So here's my sequence. Now these are not necessarily arithmetic or geometric. They could be. This one actually happens to be arithmetic. I'm just adding one repeatedly. What do you think the nth term in this list would look like? Well, it would just be whatever n is, right? Right? So it would just hit n, and then it would keep going all the way to infinity past n. So the nth term of that would just be n. Do you guys agree? Makes sense? Yeah. Right? If n is the 8th term, then a sub 8 is 8, right? Good, good. So how about this pattern here? It's multiplying by 2. What would the nth term be in terms of n? Yeah, it's just 2 times whatever n is. The first term was 1. 1 times 2 is 2, right? So, sorry, the first term was 2. Yeah, good stuff. And also I want to point out that this was not the even numbers. So, wait a minute. That's not 2n. Because 2 times 3, the third term would have been 6 here.
Oh, is it n squared? No.
No?
No, it's n to the x.
What are these? 2, 4, 8. The next one would have been 16. 2 to the nth. Whew. Man, I almost accepted the 2n answer. That would have been embarrassing. Well, I actually did, and I am embarrassed. So, yeah. No, this video is going to be amazing, unlike the last one. Man, past Mr. Waddy, what a crazy guy. So, this next pattern, 1, 1/2, 1/3, 1/4 would be next. I could have thought of this one as being 1 over 1 if you wanted to. What do you think the nth term is? 1 over n. Correct. Now, I've got a question about this last one. Kind of an interesting thing to consider, perhaps. Actually, maybe I'll even call this a consider. I don't think we've had a good consider for a little while. Consider the following. Actually, I don't think I ever put consider in a box, do I? Wow, I just did. Wow, this is weirdly blurry over here. Aha! For our internet viewers, there was a water bottle like right here, and I couldn't see it, but it was just distorting my view. So anyways, well, I was like trying to figure out what was going on, if it was electronic, if there was a water droplet on the lens of the projector. Who knows? Who knows? So here we go. Here's the question. What is the sequence approaching as n goes to infinity? Like, what number is this getting closer to? What are your thoughts? Closer to 0?
Yeah.
Is it ever going to be negative? Is it ever going to be 0? Right? Because, I mean, like, think 1 over 100 is like 0.01. 1 over a million would be like 0.000000, some number of O's, 1. 1 over a Google would be 1 O, like, or sorry, would be point, lots of zeros and then a 1. It's getting like smaller and smaller and smaller. it's approaching 0. If you wanted evidence of that, you don't necessarily have to draw this little picture here, but I've got the first 20 values of n here, and you might agree that this appears to be somewhat asymptotic, as you might recall. And yeah, it is actually getting closer to 0 and never going to reach it. Now notice the graph of these values technically would not be connected as I just did. They are discrete points because technically I can't have like a half term or a 1.5 way between two terms. So that's why they only show up on the grid. So this will never be negative, it will never be 0. And what is it approaching? It is approaching 0. Is it ever going to get to 0 though? No. So what we might say as mathematicians regarding this concept is that its limit is 0. Okay? So the mathematical concept of a limit is a value that terms approach as the number of terms increases infinitely. I feel like that's not Englished correctly, but I'm going to roll with it. Whereas the value of n approaches infinity. That's fine too. Yeah, definitely spelled that wrong.
Totally spelled this.
Yeah, good stuff, good stuff. Yeah. Let's see. Our internet friends will never know the difference. What? No.
No, I definitely use cookies. We're good.
There we go. We're good. Good enough. So, yeah, the mathematical concept of a limit. I don't know if you've ever seen this notation before. LIM means limit. Think about the word limit in terms of everyday life even. You might think of like a speed limit of 30 miles per hour.
You always get mad when somebody's doing below the speed limit.
True. Although in the case of mathematics, even though my terms are never going to be going 30 miles an hour, so to speak, the limit is 30. Like that's it's actually, yeah, in some respects it's a less than or equal situation. But if I'm talking about the limit, we with confidence actually say the limit was 0. It's never hitting that value. So this is an equal sign, this part here, even though the value of those are never going to equal 0. But that's what they're approaching, right? They're getting really, 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 really close. So this is the idea of a limit. And the way you would read this is the limit as n approaches infinity of 1 over n. All right, so the of part is kind of the expression representing the nth term. And limits are actually going to be oh so helpful later on when we are doing some calculus. So let's consider some other limits. Let's see, let's do a little example here. I'll have a handful of little parts of this example. Also, I ended up, since I don't actually have math type, I use equation editor. I didn't have my limit notation, so I had to use Google Docs version of math, and it's okay. But at least they had limits. So, the limit as n approaches infinity of 1 over n to the r. So, what are our thoughts about this? What do you think this would approach over time? Yeah, it would approach 0, you're thinking? Yeah, do you guys agree? Yeah. Would that be true for every value of r?
Negative.
Right. Why? What would happen if it was negative? Yeah, if r was negative, it would flip it on top. And then you're right, it would be approaching infinity, which actually brings up a really important point. If it's approaching infinity, we would actually say that the limit does not exist. Okay? because infinity is not a number, it's kind of a concept, right? So you would just say the limit does not exist because it is approaching infinity. And actually, for it to approach infinity, that means it's actually not approaching a number at all. You know, it's just getting larger and larger forever. How about this one? Now, I mean, I'm subtracting 1,000,000 from n. So that's going to like take care of that approaching infinity part, right? And dividing a small number by another number. What's going to happen as n goes to infinity? What's this denominator getting close to when n approaches infinity? I'm basically asking the question, what is infinity minus 1,000,000? The overall limit? You are correct. The overall limit is 0 because infinity minus 1,000,000, 1,000,000 is like nothing to infinity. It's like if I went like onto the train tracks with a BB gun as like a huge locomotive was bearing down on me and I shot a BB at the train. Like, is that BB going to do anything to that train? Not really. That train is going to keep coming at me and it's bad news for me, right? So the idea is that 1,000,000 does nothing to infinity. It can't put a dent in it. So this whole denominator is still approaching infinity, or it's going off to infinity, right? And a small number divided by an extremely big number is a very, very small number. And in this case, it's equal to 0. Okay, still toying around with this idea of limits. So how about this? The limit of 1 over n minus n does not exist. Well, let's see. That's the same as the limit of n approaches infinity of, what's n minus n equal to? 0. 1 divided by 0 is undefined. Yeah, because you can never divide by 0. Interesting stuff. Interesting stuff. So limits, by the way, I'm sorry, there's not a shorter way to write this. Limit as n approaches to infinity. You kind of have to keep writing that a lot, sadly. But let's consider this situation. So here I've got a sequence that is infinite, okay? This is my equation for the nth term. It's this ugly thing here. And my question is, what happens as n approaches infinity? What is happening to this expression? Now, estimate the limit. I don't know if you guys have any thoughts on this. 7n squared plus 2. Well, what's the numerator getting closer to? Infinity. What's the denominator approaching? Now, infinity divided by infinity, in some respects, you would think is just kind of, is that like equal to 1-ish? Kind of? Like a big number divided by a big number is going to be close to 1, right? Like 5 divided by 5 is 1. 10 divided by 10 is 1. A googol divided by a googol is 1. But these are approaching infinity, kind of numerator, denominator, but together they aren't. This plus 2 really doesn't have much of an effect on it. This plus 3n actually doesn't have any effect. The n squared greatly surpasses the influence of a 3 times infinity. Squaring infinity is way more influential. So these are kind of negligible in some respects. And I'm left with kind of this part here. And if we were just to kind of like cancel this out, Math 3 style, what would that fraction become?
7/2.
Yeah, 7/2. And it turns out that is going to be our answer. This is 7/2. But in order for me to justify that to you further, we need to know some more properties of limits. And I'm going to put this whole thing here for you, but I don't think I need you to write this down. I think we'll be able to summarize it rather well.
Why is it not on the sheet?
Well, because I don't think it's actually needed. I'm going to summarize it in a single.
It says live in Lima.
It's a. Where did I make a mistake? Lemon lime.
It says Lima and limb.
Oh, like limb, like a
Yeah, it's like
an arm that's been. I guess a limb can still be attached. That's good news. That's good news. Yeah, Lima. I like it. Lima, I believe it's how it would be pronounced. No, I don't know. Or is that how you'd pronounce just the capital of Peru?
Well, what about the Lima bean?
Yeah, that's not a Lima bean.
The lean bean.
Yeah. Where were those originally from, though? That's a good
The
question.
ground.
The ground. So theorems for limits. Like I said, don't write this down. This is found on page 776 of your text if you're interested in finding it there. But I'm going to summarize it in a single sentence for you in a moment. But let me walk through these. It says, if the limit as n approaches infinity of a sub n exists, and the limit of as n approaches infinity of, that actually should be a b sub n right there, exists. I'll just write that in right there. Bam. And c is a constant, then the following theorems are true. Could someone summarize this first thing? What would you express that as? What do you think that means?
Line. A n equals B7 equals B7 equals.
You can separate the stuff in parentheses.
Right, the limit of a sum is the sum of two limits.
Yeah.
The limit of a difference is the difference of two limits. Okay. The product, or the limit of a product, is the product of two limits. The limit of a quotient is the quotient of two limits, where the limit of the denominator can't be 0 because that would be undefined if that was dividing by 0. And the limit of a constant is just the constant. So like if I said, like for instance, what's the limit as n approaches infinity of 3? What is 3 approaching as n approaches infinity? It's approaching 3. Like it's just staying 3. It's not being influenced by n at all. Right, so the limit of a constant is just equal to that constant. So here's my like fake-ish math slang explanation that maybe you could write down that summarizes this entire set of theorems. And I think you guys might agree with that. If I kind of think of this like I can just distribute the limit over those things. That's not actually mathematically appropriate to describe it that way, but I think it kind of visually makes sense. You can write this part down. The limit can be distributed, so to speak, over addition, subtraction, multiplication, and division. I wonder if I hummed a song so well that YouTube recognized its sound waves as being the same of copyrighted music, if it would then like boot my video or add like the little copyright thing down at the bottom of it automatically.
I think the Muppet song is not here.
Really? It's public domain?
No, I said it.
Okay. Because yeah, I had a feeling Jim Henson would say, "Mana, mana, that's my music." Come on.
Jim Henson said.
Yeah, let's take 60 seconds of silence to remember Jim Henson as we finish writing this down. Sorry, Jim, you don't deserve 60 seconds. Whoa, that was harsh. Sorry. So guys, let's take a look back at the previous example. And I'm going to show you a different technique for it besides kind of like my general like, ignore these things concept. And this is the general strategy. It's a one-step method, I guess, kind of. The trick is you divide each term by n to its largest degree. Okay, so this is the general strategy here, so to speak. Let's see, so limit. So this is the same problem we had earlier. I'm expecting it to approach 7/2. That approaches infinity. Now, looking at all of the n's here, what is the largest degree of n present? N squared, right? So I'm going to divide each of these terms by n squared. So I'll have 7n squared divided by n squared plus 2 divided by n squared all over 2n squared divided by n squared plus 3n divided by n squared. So just like everybody gets divided by n squared. And really, if you think about what I actually did, I kind of multiplied by 1 over n squared over 1 over n squared, which is really equivalent to 1 if you think about it. Oh, squared, there we go. And right, if I just distribute that to each of those terms, that's what I'd get. But I don't think I need you to write this step each time. I'm fine with you just kind of thinking of like, I'm just doing this, right? And that's fine. So let's simplify this. So this is the same as, and I'm sorry, we have to keep writing the limit. It's mathematically untrue if you don't write the limit every time until we actually take the limit. Yeah, that's all right. There we go. Close enough. 7n squared divided by n squared is what? 7 plus 2 over n squared cannot be simplified. Over. Yeah. Let's see. There we go. 2n squared divided by n squared is 2 plus 3n divided by n squared is 3 over n. I like it. Now, based on all of our properties, this limit could now theoretically be distributed to this guy, this guy, this guy, and this guy. And I could just have like the limit of 7 plus the limit of this all over the limit of that plus the limit of that. That's kind of what our properties just said a moment ago. I'm not going to have us write that down. I'm just going to have us answer the question. What is the limit of 7 as n approaches infinity? What is that actually approaching? Like if I just did the limit of 7. What is 7 approaching as n gets bigger and bigger and bigger? Just plain old 7. Is 7 being affected by n? Is it being multiplied by? It's just approaching 7. Okay, all right. Plus, what is 2 over n squared approaching as n approaches infinity? Small number divided by an infinitely large number is approaching 0. No, because I'm actually taking the limit now. I'm evaluating these limits. So the limit as n approaches infinity of 2 is 2, and the limit as n approaches infinity of 3 over n. 3 divided by an infinitely large number is 0, and you guys can probably agree that this is equal to 7/2.
So do you evaluate the limit of every term?
Yeah. Yep. Yeah, so you essentially, I mean, if you want to write the step where you actually wrote limit as n approaches infinity 4 separate times there, be my guest. Be my guest. So let's try one last problema. And we'll call it a day. I'm trying to think of more lyrics to the song that says, take it to the limit, but I can't right now, sadly. Is that the name of the song? Oh, is the next line in the song? So I just have to say take it to the limit one more time after I said it the first time? Here, let me macro this a little bit more. It's a little blurrier, but that's fine. Bleh. So the limit as n approaches infinity of 2n to the fourth plus 3n squared minus 1 all over 6n to the fifth minus 2n. So let's take it. Let's see. What am I going to do? I'm going to divide by the largest n degree. So that's the limit as n approaches infinity. Which is not how it's pronounced, but I like mispronunciating things. I know, Miranda. I know. What's my largest degree? N to the fifth. Let's do this. Plus 3n squared divided by n to the fifth minus 1 divided by n to the fifth all over 6n to the fifth divided by n to the fifth. Here we go. Minus 2n. Lots of n to the fifths there. But this is going to simplify oh so nicely. So, this first term, what does that simplify to be? 2n? 2 over n, okay. This one is 3 over n cubed, I believe. Minus 1 over n to the fifth can't not be simplified any further. This guy simplifies to be 6 and minus 2 over n to the fourth. So instead of distributing this limit and taking the limit of 5 separate things, I trust you to just take the limit of those 5 separate things. What is 2 over n approaching, or as n approaches infinity? 0. 3 over n cubed? 0. Small number divided by an infinitely large number cubed.
0.
Right, that's 0, yeah. And then this one, yeah, if I raise infinity to the 5th power, it's even more infinite. Oh my goodness, that's terrifying. Subtract 0. What is 6 approaching? 6. Yeah, he's just like hanging out. He's chilling. Loitering even. 2 over n to the fourth is 0. So this simplifies to be 0 over 6, which is 0. How exciting was that? Aww. Yeah. Yeah, it's a lot of work. But we'll learn some different strategies tomorrow as well. Thank you for watching, Internet friends. Bye-bye.